We're asked to write an algebraic expression to represent each verbal sentence. First one, 2 more than 4 times the cube of a number x. Now you might look at that and think, I have no idea where to begin. It's perfectly fine, perfectly normal. Just need to go back and remember a few things. Some common words to remember. Sum is the answer to an addition problem. So when you see or hear the word sum, that means you are adding. Difference is the answer to a subtraction problem. So when you see or hear difference, that means you are subtracting. Product is the answer to a multiplication problem. And finally, quotient is the answer to a division problem. So when you see product, you're multiplying, and when you see quotient, you are dividing. When you see the word squared or hear something is squared, that means you're multiplying it by itself, also represented with an exponent of 2. 3 squared is 3 times 3, which of course would be 9. When you see cubed, that means you're multiplying a number by itself 3 times, represented with the exponent of 3, taking 4 times 4 times 4, multiplying 4 by itself 3 times. Algebraic expression, which how we started out here, that's what we want to get. It's an expression that contains at least one variable. Examples would be x plus 4, 3z, a squared plus 4a plus 5. Those are all algebraic expressions which are different than equations. An equation contains an equal sign. It's actually 2 algebraic expressions on each side of the equal sign. So an equation is a mathematical sentence where 2 expressions are equal to each other. Examples would be x equals y, 2x plus 5 equals 3x minus 7, and z squared minus 5z plus 4 equals 8. Those are all equations. They are expressions separated by an equal sign. Now, back to where we were. Again, write an algebraic expression to represent each verbal sentence. 2 more than 4 times the cube of a number x. So we reviewed those words which are going to come into play here, but you may be wondering, where do you start? Well, break it down. Don't look at the whole thing. Break it up into sections. We'll start with this cube of a number x. Cube of a number x, to cube the number x, just take x to the 3rd power. Then it says 2 more than 4 times that. So 4 times the cube of a number x would be 4x to the 3rd. And then we need to include 2 more than 4 times the cube of a number x. So that means 4x to the 3rd plus 2. We take cube the number x is x to the 3rd. 4 times that would be 4x to the 3rd. And then 2 more than that would be adding 2 on to it. The quotient of 5 less than the number x and 12. Again, where do you start? Well, you zone in on one area. Don't look at the whole thing and be overwhelmed by it. Zone in on one thing. The quotient of 5 less than the number x. So that 5 less than the number x, that's where you could start. 5 less than the number x would be x minus 5. Now we're looking at the quotient of that and 12. So quotient again means divide. So take that and divide by 12. So that x minus 5 that we had earlier, 5 less than the number x, the quotient of that and 12 would be that x minus 5 divided by 12. The cube of a number y increased by 4 times the same number. The cube of a number y right there is where you can start. That is y to the 3rd power. Increased by 4 times the same number. So increased means we're going to be adding, and 4 times the same number again would be that 4 times y. So 4 times the same number is 4y. The cube of the number y is y to the 3rd. And we're increasing here. We're increasing this y to the 3rd by 4 times that same number. That would be y to the 3rd plus 4y. Again, we are writing an algebraic expression to represent each verbal sentence. The next one up is 3 times the difference of a number z and 8. So again, you're wondering, where do you start at? Well, zone in around the variable. The difference of a number z and 8, you would write that as z minus 8. Remember, the word difference means you are subtracting, so that is written as z minus 8. Now we need to take 3 times that difference of a number z and 8. But you got to be careful here. You're not just multiplying the z by 3. You're multiplying that entire z minus 8 by 3. So we're going to enclose that inside parentheses and put a 3 on the outside. We're now taking 3 times that difference of a number z and 8. So 3 times the quantity z minus 8. Next, we have the difference between the product of 4 and a number y and the square of the number. So again, where do you start at? Zone in on the variable. The product of 4 and a number y, you could write that as 4 times y. The word product means you are multiplying, so take that 4 times y. The difference between that and the square of the number y, well, the square of the number y, you would write that as y squared. Again, when you square a number, you're multiplying it by itself, also represented with an exponent of 2. So we're taking the difference between that product of 4 and a number y and the square of the number y. So it'd be 4y minus y squared. That is the difference between the product of 4 and a number y and the square of the number. 4y minus y squared. We're going to switch gears here and we're going to write a verbal sentence to represent each equation. So we're starting with the equation 6x equals 72. We're going to write a verbal sentence that represents that. So talk through it to yourself. What's going on here? The 6 is being multiplied by the x, but we don't want to say 6 times x. You would say the product of 6 and a number, or the product of 6 and a number x. The equal sign, we're going to replace that with the word is. And then on the other side of the equal sign, nothing fancy there, that's just 72. So there is your verbal sentence. The product of 6 and a number is 72. We have n plus 15 equals 91. That's how most people would say it. You're adding the n and the 15. Remember, the word that represents addition is sum. The sum of 15 and a number, the equal sign is going to get replaced by the word is. And then on the other side, that's just 91. So there is your verbal sentence. The sum of 15 and a number is 91. A little more complicated on this next one. 2c equals c squared minus 4. You're multiplying 2 by c. You're squaring the c on the other side, and you are also subtracting 4. So we'll start with this 2 times c, as most people would say. But think of the word that represents multiplication, that is product. You could say the product of 2 and a number, or the product of 2 and a number c, if you want to include the c in that. The equal sign gets replaced by the word is. We're squaring the c and we're subtracting 4. So a lot going on there. That's squaring the c, or c squared in words. You could say that's the square of the number. And then subtracting 4. Remember, subtraction, the word that represents that is difference. So you'd say the difference of the square of the number and 4. So there is your sentence. The product of 2 and a number is equal to the difference of the square of the number and 4. Once again, the product of 2 and a number is equal to the difference of the square of that number and 4. Wording does not have to match exactly. You may have something that's equivalent to this and you would still be right. You don't have to match the words exactly. For example, if we go back to the beginning, the product of 2 and a number, if you said 2 times the number c, that would most likely be counted correct as well.